Now, the two of you have created many of the labs that we've used in the course. So how would you say that using the JADE tool to do design is similar but different than, or similar and different than the tools that you've used in engineering here at Cornell?
So I found that JADE is similar to some of the stuff we would use in, say, Digital Logic. However, in those courses, we also were able to code to set up modules instead of just having to draw them. Or, I mean, I guess depends on what you would prefer, but that was also a large part of the other courses we've taken, is coding instead of visually mapping out everything.
So can you talk a little bit about that? So with JADE you have schematics, and so what is the code? How do you express things in code? What do you mean by that?
We used like hardware description languages, so like Verilog is one of them. So that's what we used in a course that we both took. And so essentially like registers and anything you want, any modules you can make in JADE, you would make them, but by essentially just typing the code, compiling code, and it's really efficient. It's really good.
Mm-hmm. In some ways, I think the JADE tool helps people to have a more intuitive understanding of what they're learning. So in the Digital Logic course that Golnar mentioned, we kind of learn about logic gates, how to draw them, and then we go immediately to writing Verilog code. And so I think the fact that students get to draw the schematics and see them work is, in some ways, an advantage.
Now, you both took my course here on campus at Cornell, ENGRI 1210, upon which this new course is based. And you've also been involved in the development of this course. So how would you say that the two courses are similar, and how would you say that they differ?
I would say that the MOOC actually has a lot of similarities between the MOOC and the course that we took at Cornell. And a lot of the basics that you should have a strong foundation in are very much emphasized in the MOOC, which I think is a good thing. And overall, the courses are pretty similar in terms of lab component. You get to build a processor in the end in both courses. And I think that's a very vital aspect of any course that teaches you about digital logic and computer organization.
It seems like the beginning of both courses are very similar as you like develop knowledge about the gates and the smaller components and a processor. But I think in your course here on campus, we learned a little bit more at the end.
So because the edX course is only 8 weeks, we can't cover everything that we can cover in a full semester at Cornell. So some of the things we left out of the edX course are, if you remember the stack, or we have not just the computing stack, but there's a memory stack where when we do function calls, for instance in C, we push arguments and pull them off. We haven't covered interrupts. We're using polling for input-output. And we haven't covered user and supervisor mode. So in a real system, you have a user mode and then you have a supervisor mode for the operating system. So those are some of the things that are in the edX course. So what would you recommend to students who are taking this course, what other courses they may take in order to kind of fill in that missing knowledge?
I would definitely recommend taking a digital logic or computer organization type of course, not only to learn the same material in more depth, but also to learn the other topics that weren't able to be covered in this course.
So any other courses?
I personally would recommend the student to learn more about embedded systems and also operating systems. So because we don't really talk about the stack on the edX course, it would be good to learn, how when you have an interrupt or you want to switch processes, what happens to the current arguments that you're dealing with for the current program that you're running. What happens to them? Do they go on the stack? And also, operating systems is a good course to take as a follow-up.
So what advice do you have for students who are interested in pursuing ECE?
I would definitely encourage students to go ahead and take classes in electrical and computer engineering. The classes definitely get difficult, so make sure not to let the minor setbacks get to you. I will also encourage them to work with others, because I think that's where I've done a lot of my learning, is working with a group. And definitely take classes in different areas and fully explore your interests, because like we talked about, ECE is a very broad field.
Now, what advice do you have specifically for women who are interested in pursuing ECE?
So my personal advice would be not to be intimidated at first, even though there might be more males in your classes than you might be used to. And definitely there are lots of organizations on campus usually to help out too, because it's a pretty well-known fact that it's a good idea to encourage women to go into STEM fields. There's organizations like the Society of Women Engineers, Women in Computing, and it's always a good idea to get involved, get to know people, and just have a good support system.
Ava Tan and Golnar Mirza. Thanks for dropping by today.
Thank you.
No problem.